Cruising above 85,000 feet at Mach 3.3, the Lockheed SR-71 Blackbird became the fastest crewed air-breathing jet ever built, rewriting aviation history. Developed by Lockheed Corporation during the Cold War, this strategic reconnaissance aircraft was designed to gather intelligence where interception was nearly impossible. The A-12, the SR-71's direct ancestor, was designed starting in 1957 to replace the U-2 after vulnerable spy planes faced Soviet surface-to-air missiles. Events in 1960 proved the U-2 was vulnerable to Soviet surface-to-air missiles, forcing a radical new approach to high-altitude reconnaissance missions. The solution chosen by legendary designer Clarence Kelly Johnson was brutal in its simplicity. Fly so high and so fast that no missile could reach you. Developed as a black project by Lockheed's Skunk Works division, the aircraft was engineered under strict secrecy to penetrate heavily defended Soviet airspace. The SR-71 first flew on December 22, 1964, at 10 o'clock PST, marking a monumental breakthrough in supersonic aerospace engineering and design. Revealed to the public in July 1964, the aircraft officially entered service in the United States Air Force in January 1966. A total of 32 aircraft were built during the program, serving as elite strategic reconnaissance platforms for decades before final retirement. Its famous nicknames included Blackbird and Habu, reflecting its honest dark silhouette and stealth-oriented design features derived from the A-12 Pioneer. Johnson's design philosophy was direct and uncompromising. Be quick, be quiet, be on time, guiding every decision made within the Skunk Works division. Operating with minimal bureaucracy and maximum talent, the Skunk Works team bypassed traditional corporate red tape to accelerate development of the spy plane. The shape was based on the Lockheed A-12, a pioneer in stealth technology with its reduced radar cross-section and flattened lifting body. However, the SR-71 was made longer and heavier than the A-12 to carry more fuel and accommodate a crew of 2 in tandem cockpits. This design supported a core speed as defense doctrine, ensuring no airframe was ever lost to hostile fire during its entire operational history. Equipment for the plane's aerial reconnaissance missions included signals intelligence sensors, side-looking airborne radar, and a high-resolution optical camera. On average, an SR-71 could fly just once per week because of the extensive and lengthy preparations needed between demanding missions. Flying at Mach 3.2 plus, aerodynamic friction heats the airframe to extreme temperatures that would instantly melt conventional aluminum aircraft structures. At top operating speeds, the airframe reached temperatures of 316 degrees Celsius at the nose cone due to relentless air friction. Johnson chose titanium for the airframe because it was stronger, lighter, and capable of withstanding the punishing heat of supersonic flight. The primary problem was that the United States produced almost no titanium domestically when development began on the aircraft. The main global source of high-grade titanium at the time was the Soviet Union, creating an extraordinary geopolitical hurdle for the project. Through complex operations, the CIA secretly purchased Soviet titanium using a network of shell companies to acquire the vital material. As Ben Rich noted, there were no manufacturers with the right materials or machines, so the SR-71 taught the industry how to work with titanium. Because titanium panels expanded drastically at high temperatures, the aircraft was deliberately designed with loose joints on the ground. On the ground, unheated fuel leaked freely through these loose expansion gaps, making the parked aircraft appear broken before every flight. Once airborne and accelerating to Mach 3, frictional heat caused the metal to expand perfectly, sealing every joint tight against leaks. The aircraft required a specially formulated, high flashpoint fuel called JP7, which would not ignite from the intense heat of the surrounding airframe. Propulsion was provided by 2 Pratt & Whitney J58 turbojet engines, some of the most complex power plants ever engineered for aviation. The engines worked like conventional jets at takeoff, but transitioned into ramjet-like operation at Mach 3, getting more efficient the faster they flew. Ingenious movable cone-shaped inlet spikes at the front of each nacelle translated forward and backward to slow supersonic air down to subsonic speeds. By trapping supersonic shock waves outside and inside the engine cowl, the design maintained smooth airflow into the compressors without choking. At high Mach numbers, bypass tubes routed air directly around the core engine and into the afterburner, generating massive additional thrust. Inside the cockpit, pilots wore specialized pressure suits, resembling astronaut gear, to survive the hostile atmospheric conditions at 85,000 feet. The instrument panels were packed with hundreds of specialized gauges, dials, and navigation systems required to manage high-speed flight manually. The standard defensive maneuver for an SR-71 when a surface-to-air missile launch was detected was simple and bold. Accelerate. At Mach 3.3 and 85,000 feet, acceleration was more than sufficient because hostile missiles always arrived too late, chasing an exhaust plume miles ahead. From 1968, reconnaissance missions were flown from Kadena Air Base in Okinawa, projecting American intelligence reach across Asia. Blackbirds flew regular surveillance sorties first over North Vietnam and Laos during the Vietnam War, and later over North Korea. From 1976, missions were also flown from RAF Mildenhall in the United Kingdom, monitoring the Soviet Union's Baltic and Barents Sea coastlines. Missions were additionally flown over Cuba, Nicaragua, Libya, and to probe nuclear weapons installations in Israel and South Africa. Unlike previous spy planes under Central Intelligence Agency control, SR-71 missions were flown overtly, with United States Air Force markings. While penetrating deep into sensitive regions, operational protocols ensured the aircraft operated along international borders rather than violating sovereign airspace directly. On July 28, 1976, the SR-71 officially set a world speed record of 2,193.2 miles per hour, approximately Mach 3.3. The same day, another SR-71 broke the world record for sustained altitude in horizontal flight at 85,069 feet. As the fastest jet aircraft in the world, its absolute speed record for crewed aerodynamic jets remains unbroken decades later. Extraordinary performance produced legendary pilot stories, such as crossing the international dateline and landing before takeoff local time. One famous mission departed Kadena Air Base in Okinawa and landed at Beale Air Force Base in California in time for Friday evening drinks. Across more than 3,500 operational missions spanning 24 years of service, not a single aircraft was lost to enemy action. Out of the 32 aircraft built, 12 were lost in various operational accidents over the years, though none were ever shot down. High operational costs and the rapid development of reconnaissance satellites eventually led to the aircraft's initial retirement in 1989. Although briefly returned to service in the 1990s, the Air Force permanently retired the SR-71 fleet in 1998. NASA operated its remaining airframes for high-speed research until final retirement concluded in 1999. The retirement of the Blackbird left an intelligence capability gap that the United States has struggled to replace ever since. Decades after its retirement, the SR-71 remains the defining symbol of crewed high-speed reconnaissance and a pinnacle of engineering. Every challenge from melting skin to choking engines forced radical innovations that turned physical limitations into design triumphs. Nothing using conventional jet engines has ever flown faster, securing the Blackbird's legendary status in aviation history. Conceived by Clarence Kelly Johnson and built by the Skunk Works, the SR-171 proved what brilliant minds could achieve under extreme pressure. Ultimately, the SR-71 Blackbird stands as an enduring testament to human ingenuity, pushing the boundaries of speed, altitude, and survivability. Its unmatched engineering triumphs continue to inspire aerospace engineers around the world, remaining an untouchable icon of the Cold War era. If you enjoyed exploring the extraordinary engineering of the SR-71 Blackbird, please subscribe to our channel for more deep dives into aviation history.